Do you want one of us to monitor YouTube chat if you're having trouble seeing it yourself? Sounds good.
From my perspective, you can ask any questions you want.
Yep, I have no qualms either.
As long as you don't ask which Azure services are still using binary format.
All of them.
Hello everyone. Hopefully this is working the way it should, because today I'm streaming from my laptop from a Microsoft conference room, which is always a recipe for fun and entertainment. So according to this, we are streaming indeed, and my CPU is not cooking yet, so that's a good sign as well. Today we are talking about binary formatter. So we, as probably most of you know, we are on a deprecation plan for this, and there's going to be some replacements for it. And today we are looking at a proposal to basically have a reader for the format that binary formatter produces. So if you store stuff in a database, this I think will make it so that you can actually read data that you already stored without actually deserializing it. But I'll let Adam drive this and see what's in store for us today.
Yeah, so as you mentioned, the first scenario that we care about is reading persisted payload, and it's important for services that cannot just stop, switch to a new format and start all of their live services. The other is for customers who have, let's say, backend APIs, which are accepting web requests from customers that are still using binary formatter. And for example, maybe there is a successful product, but the company no longer exists, and they just have to keep supporting it. So we want all of them to have the possibility to read the payload without loading any type, instantiating any types, doing all kinds of bad things like unbounded recursion and things like that. So basically a safe reading. The first thing I wanted to discuss is the namespace. So both me and Jeremy Cooney got to the same conclusion in parallel, independently, that we could call it system runtime serialization binary format. Jan Kotas mentioned that maybe we could call the library and namespace Microsoft NRBF. And by the way, NRBF stands for .NET Remoting Binary Format. I don't have strong opinion here. However, System Resources extension is going to rely on this package. So this is why I'm not sure whether Microsoft prefix for the package and namespace name is a good thing. Should I just continue or do you want to discuss the namespace first, then the type names first?
I mean, I didn't quite catch the concern for the Microsoft namespace.
So some system packages are going to depend on this package.
Oh, I see what you're saying. Yes. I mean, to me, it is a Microsoft-specific spec, but I mean, it's part of the .NET platform, so it might as well be system, yeah.
Any reason it wouldn't be system formats in RBF?
I mean, the only reason why we might want to put it under the serialization namespace is because that's where everything else is, but I mean, given that we don't want people to use serialization, it does seem a bit odd if we put it literally right next to it, right? I mean, do you have any sort of API dependencies on things in the serialization namespace, like enums or stuff?
Like what kind of APIs exactly?
No, I mean, do you have like any API dependencies on things that are in the serialization namespace, or is it all self-contained and we could put it anywhere we want?
No dependency on anything related to serialization.
So if there's no enum dependencies or anything like that, it does seem... It's an interesting candidate. I actually like putting it in formats, especially because
I
you
like
kind of
that too.
think of it as an advanced scenario, right? And so we don't want to put it in a core namespace. Not that serialization is a core namespace or anything like that, but I just dislike putting it right next to it, given that we don't want people to use it.
Well, I'm thinking back to like the ASN1 work that people did a few years ago, and the APIs on that allow things like, hey, let me read this primitive string, let me read this primitive time, this primitive int, and so on. And the APIs that Adam's bringing feel like they're in the same realm.
Yeah, that's true. I think it would be slightly different if serialization would be a thing we still want people to use, and this is just a more low-level access to it. Then I think putting it in a namespace that seems related to it makes a bit more sense. But given that that's not the path, the path we're on, we might as well put it, where all the other formats are.
Sure. I guess maybe it would help to level set. Like when you're using the term serialization, I assume like you're using object model serialization, like that you're talking about rehydrating objects from a stream, whereas what Adam's doing is primarily a protocol parser.
Right. Yeah, I mean, if you compare it to JSON, right? I mean, JSON, as we said, we could have put it in system.formats.json, right? But like, I think the question is now, like, if you have serialization and a reader and writer for JSON, it does seem like you kind of want them under some common namespace and not like be super far apart, right?
Right.
And so, if you say, oh, the JSON format should go into system.format, the serialization should go somewhere else, that would be rather odd as a choice there, right? But in this case here, I think it makes sense to just leave the system runtime serialization namespace behind and just call it, I don't know, what was the suggestion, system.formats.nrbf or?
Yeah, those were the words that came out of my mouth.
I mean, I'm fine with
I mean,
NRBF.
it is correct.
That's the spec, right? But
yeah,
It's correct. It's simple. I like it.
I mean, the question is really, were people going to be upset about the abbreviation, but that is the name of the spec. So.
yeah.
I assume that means we would still keep the prefix though, right? In the type name, right?
Yeah.
Yeah. All right, so I think in namespace then we discussed to death. You want to just keep going?
Yes. So the first step I wanted to introduce is the reader, an RBF reader. And the first thing we need to do is to decide to let our users know whether given payload contains binary format data or not. As you said, users might be persisting in the database, and at some point of time they might migrate, so it will be no longer binary format. And checking that is, if we just check for the header, we have a very good convenience that it's actually binary format header, binary format payload. And I have two overloads. One is accepting a stream, and another is accepting a byte array. I wanted to introduce the overload for byte array because when I was analyzing open source repositories, I have very often seen that people have a byte array and they just create a memory stream to be able to deserialize it. So I just hope maybe if they move to a formatter that accepts byte array, they won't need to create a memory stream if it's not a binary formatter. So just for a convenience.
Is there any reason why we don't support span?
Yes. So initially I wanted to support span, but this package has to support older monikers, and checking all of the bytes and parsing everything on full framework using span isn't as easy and convenient as it is with all of the nice APIs we have in .NET, especially when it comes to taking care of big and little endian stuff.
So if we cared enough, we could do a TFM split, right? We could say, if you're on, I don't know, whatever the baseline is, net 7, net 8, then you have the overload. If you're targeting net standard or something older, you don't. But we don't have to start this way. Presumably right now you're targeting net standard or something?
Yes.
Yeah. Yeah.
To be exact, Net Standard, Full Framework, and .NET 8 and 9.
I mean,
Gotcha.
this particular method could support span with no cost, right? Like you're just reading like 4 bytes.
Right.
You're actually reading the first byte to check
Yeah.
whether it's 0, if I remember correctly, and then the next 4.
Okay,
You're reading
5.
17 bytes. It takes 17 bytes to tell if it's a binary format or payload or not.
Sure. But I think the point still stands, right? If you presumably you do the equivalent of a, some numbers plus a magic value that you compare, right? So
Yes, we basically check if the first value is 1, the another is 0, and the other 2 are not negative. So
yeah. I think we have APIs for that.
But
yes.
but I do want to defer to what Adam was saying though. Like if you're using binary formatter today, like all of those APIs are stream. Like if we're adding non-stream APIs, like we're giving you something that you weren't able to use in the first place. So like, what did we actually give you?
No, that's fair. Like, I mean, I think the reason I was asking is because I think it depends on where the stuff is going, right? If we are saying, the stuff might be in a database, right? Then what I think will happen eventually, like, the database is going to be modernized, moved somewhere, and then you start using modern APIs to read contents of the database, and then suddenly you may find yourself in cases where, the input is more convenient if it happens to be a span, right? Or more performant or whatever, right? And so, given that these are all synchronous APIs, it seems like, modulo the parsing concerns that Adam has would be unfortunate if we can't easily do it. But yeah, there's probably not a lot of demand for this right now. So I guess either way works. And then presumably when you call read, you throw an exception when it's not a valid binary format?
Exactly.
Yeah.
Anytime we encounter data that is invalid binary formatter stream, we throw serialization exception.
What is it?
Teams is frozen.
Oh, Teams is frozen? Oh, great.
But
It didn't.
We can still see you and hear you just fine.
Oh, no, because I have 2 windows open. Like, I'm scrolling a different window. I have
my
own
scrolling and talking about things.
I have my own copy. So when I scroll around to just think, I'm not confusing everybody. Yeah, so the you were saying, Adam, like you're
honestly I forgot, but I think we can move on to the next method,
So
the read method. So the read methods, we accept a stream, payload options, which is an option back, and a Boolean optional argument that allows it to leave the stream open. And what we return is serialization record. So this is the most important method. It has an overload that also provides the users with a record map, which is exposed read-only dictionary of into serialization record. This method is going to be required for the super users, like, for example, the simplified deserializer Jeremy wrote for WinForms, because the record map is required. And just for convenience, I also wanted to export read class record method, because I suspect that most likely people will be reading class and struct information, so they will be constantly like doing the cast. Read any serialization record and cast it to class records. So just
gotcha.
For convenience.
But all of them read the entire payload, right? Basically, after you call read, there's no more reading, right? It's just data.
Exactly. They read the entire payload and they stop when they encounter the end message byte.
Gotcha.
So in that sense, it sounds like the type isn't actually a reader. Because I think everything that we have that's called a reader has stateful read methods, and when you call read, it's like move on to the next thing. Like
I guess
you could imagine
the stream, the
that's
JSON
true.
reader advances the JSON payload, ASN reader advances the read is an instance verb that changes the state of the object it's called on, and a reader is an object that has a read method. So I don't think we can call this read or reader.
So you could imagine that this is actually reading the graph and giving you back the graph, and if your stream contains multiple graphs, you could call read over and over and over again to get all the different graphs in the stream.
Right, but you don't ever have the fact that it's a static class means I don't think it's a reader. It's a decoder.
I mean, from an object model standpoint, I mean, you could just move the read methods as as static methods on serialization record, right? You would say serialization record dot read, and you get back a serialization record, right? And then you could have class record dot read, which gives you back a class record.
Yeah, that's possible. But then, if we split it, I'm not sure if it will be easy to find the starts with payload header method.
I mean, presumably that would be logically part of the serialization record, right? Because that's where the format is, right?
There is a special record that is the start of message record and a special record that is the end of message record. And I believe, Adam, your proposal does not expose either of those to the caller, correct?
Correct.
Because there was no reason for anyone to ever look at them.
I mean, to me, that's kind of like, whether you have it on its own type or whether you put it on the serialization record, I think makes no difference, given that you don't expose them.
Yeah, I mean, I'm just saying change reader and read to decoder and decode.
So I'm fine with the rename Jeremy suggested, but I would rather be against moving them to the record types.
What would you call the class then?
So again, for system formats ASN1, we have ASN reader, which is the stateful thing, and we have ASN decoder, which is the stateless thing.
So you would call
it an
RBF
decoder.
Yeah, sure, that works too.
Sure. That also means that if you ever did want to expose, Adam, in the future, a reader which gave you the raw records as opposed to the graph, then you could expose that in the future too. And call that an actual reader, because that would match your terminology, right, Jeremy?
Right, that would be that consumes one thing and tells you what it consumed, which would be the tar reader, the ASN reader, the stream reader. Like all these readers are, I read one thing and leave the stream position with the next one.
And just one side note, it was possible to implement binary formatter deserializer on top of these APIs, only the public ones. Okay. Should I start discussing the payload options?
So the dictionary is just basically the entire data structure, right? As a thing in the int. What is the int? Is just a random ID basically. That's part of the format.
Yeah. So every serialization record comes. Maybe not every, but the ones that we care about come with an ID, which is just an int32.
So it's basically like the JSON format for graphs.
Any record that can be referenced has an ID. Some of them can't be referenced because they are top level or metadata within another record or something.
Since an out is basically a return, I'll ask the question of should it be an interface or a concrete type?
The reason why I wanted to return an interface was to not expose a concrete type. And because so what we want to have is like a dictionary that is read only for the users. They cannot add anything to it using any kinds of hacks like casting a read only dictionary to dictionary and calling add method. And another thing is that it needs to use custom comparer to avoid collisions. And that's it. And I was hoping that
you're returning a custom type.
Yes, I return a custom type that implements this interface.
Okay. So if you're returning a non-public custom type, then that's the best answer.
Yeah, I mean, I did. You saw my comments in chat earlier. Like, I do wonder if exposing this dictionary is useful to people, because I think exposing it does potentially lead consumers into a pit of failure. But we could talk about that maybe
It's a
later on.
It's a valid
The
question.
problem-
Jeremy, go ahead.
You want me to have a comment there, Adam? Like, basically, there's no way to follow the graph with references when you, at least more complicated graphs, unless you can look up individual records like library IDs and things like that to do comparisons. So for identity, it's super helpful.
And
Yeah.
would you ever consider having a standalone object ID struct type and having your read-only dictionary of object ID serialization record instead of using int? Make it literally an opaque value type.
Yes, and this is exactly what Jeremy did in his prototype.
Because that would actually be safe, unlike dictionary of int serialization record, which is not safe.
So what is
I
safer
did that.
about it?
Dictionary of T key T value, if T key is anything other than string, is subject to collision attacks unless the constructor of the dictionary goes out of its way to secure it. And the way that Adam's working around this right now is he's creating his own dictionary instance with his own custom comparer, but I don't think a consumer of this API would know that if they needed to clone this dictionary, they would have to write their own custom comparer if they wanted to be safe. What they would probably do is they would just iterate through it through a for each, add all of those things to their own dictionary, and then all of a sudden they fall over. Because remember, the keys are under attacker control.
Right.
Yes, but why would they want to create a copy of this dictionary?
Because you're giving it to them, and maybe they want to serialize it somewhere.
Serialize
But it's already serialized.
So, I mean, one option there is to make another API that only allows you to look stuff up by int, right? So you can't iterate it or anything or do any other weird stuff.
That will work too. I mean, that's iLookup effectively.
Yeah. So, I mean, that's what I had done in my own implementation of this. Is like I totally made it opaque. There's only an indexer on the interface.
I don't think we should be exposing the int at all to users, though, honestly, for the object ID, because I have this vision of consumers like, oh, I'm just going to look at the largest object ID I got and do new int largest value, like boom, fall over dead. Or I'm going to have a hash set of int to try to detect cycles, boom, fall over dead.
And there is a null ID too, so I mean that's part of why I had an ID struct, so I could encapsulate all that. Yeah.
So
because like zero is not a real value per se,
right?
Because you can actually by the spec have zero as an ID, which leaves you with nothing left for null.
Yeah. Are you suggesting that zero is not a natural number, Jeremy?
Depends on which definition of natural numbers you're using,
well,
right?
it's a place of failure, right? Because the spec technically allows it, and then like in many places we assume zero means null, but like zero could be a record ID.
Mm-hmm.
Sweet.
For these purposes, right?
I mean, I don't have any sort of opinion on this. Like, I mean, we have many other formats where we basically expose a handle type, which, you know, is usually just a glorified int anyway. So it seems like not unheard of. I think people would know what it means. I mean, object ID has the nice other benefit that it tells you what it is. And int is kind of like, well, I think it's an ID, but I'm not sure. In terms of dictionary type, is there any concern then with saying I read only dictionary of object ID, comma, serialization record, or would we want something more typed than that?
From a safety perspective, I think that's desirable, but like Adam, Jeremy, I'll cede the floor to you.
Yeah, from the user perspective, the only thing we needed in the deserializer was have the ability to check if given thing is present in the dictionary, and if so, access it. So basically contains or try get.
And an object ID could be the opaque way for you to look that up. Because we don't actually need to return the int. Like the user never really cares what the int is. Like it's literally an implementation detail of the protocol. They should never be looking at that number.
Right.
Correct.
Yes, and in my initial implementation, I was not exposing that, but when I was switching Jeremy's deserializer to use it, I had to do that.
Makes sense.
So Levi, you want it you want it to be a struct that has a field but no properties?
Correct.
Okay.
I'll copy in what that looked like for mine as to discussion.
And it implements IQ tables, so people can copy the dictionary. Okay.
Yep, it would have typical operators, IEquatable, and get hash code would be randomized to prevent dictionary attacks.
So my only question is how to call it, because ID is most likely too simple, object ID also quite simple to generate.
Serialization record ID.
Okay.
That works. I mean, object ID, in my opinion, is also fine because as soon as you have two words, it's usually fine.
You don't think there's an object ID anywhere in?
I mean, there might be, but like at the same time, it's like you know, we don't have to be collision free, right? It's just you need to have should be collision free in common cases, right? Which
it's a good thing cryptography doesn't use object IDs anywhere.
We don't. We use OIDs.
yes,
OID,
OIDs
yes.
sounds like a
So
Europop song somewhere is coming. So Jeremy, you're okay with read-only dictionary as the output type, or would you like something else?
No, I'm fine. I asked the question. His answer was he's returning a non-public type. So
Okay. All right.
That's the
fine.
most public we can make it.
All right.
well, Levi, weren't you suggest? I mean, read-only dictionary has more on it than strictly necessary. Was that part of your concern, or do you care?
Oh, I don't. My concern has been addressed. So feel free to return a dictionary if you want.
So as long as it's an ID struct,
Right.
not int. All right.
Yeah.
So I copied into the internal chat the implementation of ID that not the right name
I don't
according
see
to our
it.
discussion here. In
It's
the meeting chat,
it's in the meeting chat. It needs to be randomized, but otherwise, like that's the thing.
Last thing I see in the meeting chat is the link to the NRBF spec.
He posted it to some chat.
No, it's in the correct chat.
it's in that one. Yeah.
And I guess my team's is not updating.
Well. All right. So then we have that. Payload options.
Yeah, so this is just an option bug for the payload as we have as of now. The first thing, public constructor, so people can create it. Second, a possibility to provide custom options for type name parsing, because the payload reader is performing type name parsing behind the scenes. Second, undo truncated type names. So there is some historical background here. So for years, we have been generating resources with invalid type names. And the purpose of this flag is to force the reader to undo that. And we need that to be able to let our users read those resources. We need it in the deserializer, but also we believe that they are common enough to be important for other users as well.
This is for RESX specifically, right?
Yes.
Yeah.
Okay.
All the historical, and so the framework stuff does this, right? And we in core we fixed that and added another resource type that doesn't have it mangled, but all of our history has these payloads all over.
Yeah. For the reference of the people on the call and watching, there was a bug in the generator in some of these where they would split on a comma and say everything before the comma is a type name, everything after the comma is a library name. But with the introduction of generics, you can now have commas within the type name itself, because it means that it's a generic declaration, and it meant that it was munging the what was written out on the wire. Now, there was logic in there that fixed it back up on the way back in, and I think that they implemented a custom binder to do that. that there's no binder concept in what Adam is proposing here. So this is just kind of a like, we'll just paper over it and fix it up for you type thing.
Exactly.
Now, do we need this property? Should it be the default behavior? Because of like, if like every other payload is with these issues potentially, like who would ever want to set it to false?
So the funny thing is, I'm looking at the type name API, and the type name API has a single parse method which just takes the final string, which is presumably type comma space library, right? So in theory, like you're going to be concatenating these things regardless, right?
Yes, but to be exact, it accepts a read-only span of characters, so I don't have to concatenate strings, but characters.
Yeah, but I guess like if presumably you're calling the public type name parse API, right?
Yes.
And if there is only a single parameter, span, string, whatever, that represents the fully qualified type name, aren't you always going to end up having logic that is type, comma, library, concatenate them, write them into the same buffer, whatever, then pass it in? Like, does this property actually do anything?
So at some point of time, I was the parser was the decoder was implemented in a way that it would stop on the first invalid type name, because I wanted to reject invalid inputs. So and these type names are invalid from the perspective of the type names. However, if you combine the type name and the library name together, they may be valid.
I see. So this, I wonder if this really means that we have to have two separate parameters into type name.parse, like one for the type name and one for the assembly name, because it turns out there is actually an attack here as well, which isn't accounted for in the design. Where, remember, in the NRBF specification, a library can be inserted into the stream once because it is its own record type, and then multiple different type records, class records, can reference that same library over and over and over again. So what it means is, if I send a single library record in the payload, and then I send 10 type records after that, all of them reference the original library record, I have, as an attacker, performed M plus N, O of M plus N work, but coerced the reader into performing O of M times N work because of all of the concatenation that has to take place under the covers. So ideally, this design would actually be, you read the library name once into its own assembly name info record, and then every single time you need to construct a type name instance on top of that, you pass only the type name plus the assembly name info instance you already have that's shared across all the different types. That would be the only way for the reader to do O of M plus N work, same as the attacker did.
Yes, and this is how it was implemented at the beginning, but then I had to add support for this backward compatibility thing. And I now don't remember whether if you have one library and 10 classes that reference to it, when this flag is off, whether I'm going to parse the library name 10 times. I would need to clarify that.
Well, I'm looking at the public API on typename.parse, and it looks like you have to, because there's no way to associate it with an assembly other than to pass the assembly as part of the name itself, which means somehow we're making a long string to pass in.
Yes, and I have created a proposal for that, to have type name dot with assembly name, where you could specify the assembly name.
Okay. So what we would want to say then probably is, like, undo truncated type names while it might be necessary for things like RESX, like this, setting this to true does in fact allow a DOS attack, because it means that you're going to have to do multiplicative work every single time a new class record comes in, even though the attacker only did additive work.
Yes. So is it okay to keep it, but with false by default? So only those who need the backward compatibility can enable it? Because otherwise,
When I'm saying stuff like this is the type of attack that this allows, there might be a legitimate reason that you have to enable this, but we would document like, hey, if you enable it, here's a consequence.
Awesome. I'm going to add a remark.
And then what would be the default? The default would be false.
Yes.
It would have to be, yeah.
Yeah.
There's no way to make it true safely if you're trying to prevent DOS attacks.
And like, what I didn't quite get is like, so when people serialize today by default, what behavior do they get in the resulting payload?
Correct one.
So when do the truncated ones appear?
RESX is the only caller I'm aware of that has this bug. Adam, do you know of others? Or Jeremy?
I don't. Maybe Eric St. John would. So,
Yeah.
Imo, basically what I know is resources persisted many years ago that are still present in the applications.
Gotcha. So it's basically just, so it's probably a bug in RESX rather than a feature of the format, right? Then.
Right.
Yeah, exactly.
Gotcha. So then, yeah.
Yeah. If you're just calling binary formatter on your own just as an everyday application, you never ever would have run into this.
That's my understanding. Is that no one else made the same mistake. But
Sure.
yeah.
So yeah, RESX had some custom logic in it which induced the bug, and like Jeremy said, maybe some other caller could have done that same custom logic, but it's something the caller themselves would have had to do. Binary formatter never did it on its own by default.
So then, yeah, I think having it is probably fine. Off by default is fine.
Yeah. And there are some other details related to this bug, because also it was using the wrong record type, because it wasn't using system class records, it was using the class records. Yeah,
so really what it probably should be called is unfuck RESX, right? That's really what we should call it.
Basically.
Gotcha. All right.
I'll give you $10 if you ship
that. Well, it would have a more politically correct name like unfudge RESX, right?
Nope. $10. It requires the unchanged name.
For $10, I'm not taking that. All right. So then, anything else to say about payload options?
We expect to extend it in the future. For example, maybe give the users the possibility to set the maximum number of fields a class should have, or a max length of an array. So it's an option back because we expect to extend it in the future.
Right. Seems fine.
So speaking of that, the stream that people pass into the read method or parse or decode or whatever it is, presumably people can check the length of the string before they pass it in, right?
Right.
So they would say like, oh, if someone's giving me more than 10 megabytes, like I'm just going to fail before I even call this. Are we making a guarantee that if you pass in a 10 megabyte stream, for instance, the APIs that you have here, a single call to read, will never do more than of 10 million-ish units of work? Typically, when we do security reviews of things, when we do security reviews, we tend to say that for the attacker doing O of n work, if the victim performs greater than O of n log n, then things really need to be looked at closely because there's probably an attack. N log n or less, generally okay. And that's actually a rule that we're starting to roll out kind of company-wide. I'm wondering if we're willing to actually document the read method as saying, like, this is a guarantee that we're willing to make. And if you find a way to bypass this, like, we will fix it.
There is only one caveat. So, like, one of the correct me if I'm wrong on this, Adam, for the current implementations and stuff, is like we presume that the stream is seekable, and we can check the length and do this sort of stuff, right? To do the validation that, like, when we can actually make evaluations about, like, what you say you've got this much stuff, does the stream have at least a bare minimum of remaining data to be able to fulfill that? the big caveat there are compressed null records.
Mm-hmm.
And that's the one thing we're probably going to need to add some stuff for. So for options to block, because there is a record, there's actually multiple records to coalesce nulls. And one of them takes an int for number of nulls, right? And with that, this is the only case where you have like completely or effectively unbounded. It's not completely, but effectively unbounded times X amount of data than what you actually have in your stream.
But do we
calling read doesn't allocate those eagerly, though, right? You explicitly have to say like, oh, create an array and then populate it with all these compressed nulls.
Yes, exactly. It did that in the very, very first preview, but you have performed code review and I have removed that and learned from it. And according to my knowledge, right now we don't perform more work than the attacker when reading.
With the exception of calling the get array thing, right?
Yeah, but the user has to call it. So just for reading the thing, we don't.
Okay.
I mean,
but that is a specific risk, though, right? So, but just calling read won't cause the problem. So we can call
exactly.
we can make a guaranteed
Downstream
read.
code,
Yeah.
I mean, but
Or
I think it's a fair
we're not calling it read now. We're calling it
decode.
I'll use the right name.
Yeah.
Decode.
I mean, it depends on how you think people process the payload, right? I mean, if the very next line the user writes is get array basically down the stream, then I think at that point we should talk about whether we want to expose the API slightly differently or something like that, right? But yeah,
we can revisit that when we hit those APIs.
Yeah. So then, I think we're done with payload options then.
Yes.
So I think the original question that Levi had is like, do we need a maximum, or are we content with saying the caller handles that and just checks the length of the stream? I think we said that's what we are content with, right?
Yeah, but personally, I would be content with that, just with the documentation note.
Right.
So I know from reviewing the current implementation of this that there are places, like it does say can seek has to be true. But then there are places that it supports position and length throwing. If we're talking about the notion that the stream is itself checkable, are we going to say we're going to require that neither position nor length throw?
That's my understanding. Adam? Like from a security perspective, my understanding is that's the right way to go, and like leave it on the users if they have a non-seekable stream that they have to make a copy, because we can't make the guarantees we want to make without being able to know what the length is and where our position is.
Well, they're seekable.
So we need to know what's remaining, basically, right?
They're seekable, and then there's countable, and those. Well, the counting status is described by can seek. Can seek doesn't guarantee it's countable.
Yeah, so we need remaining, basically, is the fundamental thing.
Like you can support seek forward without knowing how long you are.
Yeah.
I suppose that's
well, like,
true. Yes.
Binary reader doesn't require a seekable input stream, but it still guarantees that it's never going to do more of O of n work.
Well, I mean,
because it just allocates on demand.
So there were comments of like checking the length, and if it's saying that the implementation here needs to check the length, then it loses flexibility.
I think Levi was saying the implementation that we provide doesn't. The caller can.
Right. The caller can if they care.
And if they have a non-position stream, they just need to drain it if they care about checking the length.
Right.
Or write a thing that blocks it from going too far.
Yep.
Yeah, that's what Nougat does, by the way.
Yeah. Okay.
So just comment on the binary reader one. So while it allocates as it goes along, it allocates without checking how much data is still left in the stream. So if you say it has int max value of items, it does not care if there's enough bytes to satisfy that.
Right.
So that's a difference between that and this one, is that this one will care to some level.
No, you're absolutely right.
Yeah, the way it's currently implemented, let's say we have a record that says I'm an array of 10,000 integers, we are just performing a check. Oh, is there 40,000 bytes available in the stream? If so, then pre-allocate an array of 10,000 integers and just read them. If we don't have this information, we just allocate a list and read them separately. But I know that Jeremy Barton isn't happy about this approach right now.
I mean,
What gives it away?
that is a very legitimate way of doing it. I'm pretty sure STJ does something very similar under the covers. But it is a legitimate way of reading
Only if the number's
packed
small.
data. Yeah.
My concern is when the number's large, it needs a different implementation, which doesn't affect the API.
Right.
Yeah.
I was about to ask, like, how does that satisfy the n log n? Because I don't think that's the growth rate that list of T has, right?
No, list of T has O of n. Adding an item to list of T is amortized O of 1.
It grows in steps, but it only grows as you add more to it. It's only ever
Right.
twice what you've asked for, so it's linear on your data.
Yeah.
The amount of copying it does is
Yeah, it was.
O
think
of
it's-
2n normally.
yeah, it's like 8n.
Yeah, something like
I know
that.
that
It is linear though.
Sure, fair enough. That's still
Array
n log
max.
n,
I
yeah.
did the math, and it came out to it copies. If you do trivial list, it copies 8 or 9 gig as part of building a array.max value array.
Yeah,
Which
so-
is fine.
Yeah, I mean, more memory.
Memory sheet.
Adam, you were saying?
Yeah, Jeremy suggested that maybe I should implement a custom collection that has a list of lists, basically, so we don't allocate too much.
If you want to.
Anyway, that doesn't.
I
affect
don't,
the
but
API.
Jeremy said
Yeah.
you
That
he's
doesn't-
not going to approve
Doesn't
the
affect
API.
the API, so move on.
Yes.
Yeah.
All right. So now I have to find the window again. All right. So serialization record.
Yeah, this is the base type for all serialization records. The constructor is internal private protected, you call it, just so other people cannot create types that derive from it. The first two properties, record type, this is the enumeration that describes the record. The second, object ID, I know it's in here, but I know it should be the serialization record ID.
Should we rename it then to record ID? Or just ID?
I like the ID name because it's serialization record.id, so
Yeah.
I need to pull up the spec.
I think in the spec it's called object ID, if I remember correctly.
There are other IDs in the spec. So there's an ID for, like, because you can have, I don't know if we expose this here, but basically you have an ID that references another ID. So you have a reference object that says, like, all right, well, the actual data about the members comes from this other ID, but my ID is different because I'm another instance, right? So there's a ref ID and an object ID. I think, if I remember it correctly off the top of my head.
Do we think that the?
I don't know that we expose that.
But we don't expose the reference records.
Right.
Do we think that the record type enum needs an NRBF prefix?
I was actually just thinking previous thing with serialization, because now we have serialization record ID, might as well have serialization record type.
That's fair.
Yeah.
Sure. And you can also drop the byte constraint on the enum.
I can't see Adam's face, but I'm imagining it's squinting.
Yeah, but now I'm about to discuss a method that has received strong pushback.
Right.
So,
Since I'm going to have to leave very shortly, I'm going to say right now, when we get to the record type enum, you have a comment that there are some values that we've left out because we don't support them.
yes,
I feel that we should add them because they're in the spec, even though we'll never return them and no one will ever see them. Doesn't mean that they don't belong in the enum. We'll see if
Yeah,
I made it that far when I come back in half an hour.
Good luck.
Okay. Okay, so let's handle another hot potato for now. Is type name matching?
Yes. Oh, here we go.
So, this is the base type. The types that derive from it is class record, array record, and primitive value record. And for all of them, you can get the type name. So in theory, users could do like a type name matching. But there are generic types. And unfortunately, binary formatter is taking type forwarding into account. So, for example, a dictionary of string to int, if you do type of dictionary string to int dot full name, you will get something that has system private corelip inside. But what you get from binary formatter is something that uses MS corelip inside. So I was hoping to expose this method just as a convenience for the users, so they don't need to worry about type name forwarding, and they would be just, is this record the time I'm expecting?
So that's the part I don't quite understand, because my understanding is that basically it's just what is it called again? A type forwarded from, right? You basically just replace the assembly name with whatever the original identity was, right? But I would generally assume when people do type comparisons, they either use just the type name without caring about the assembly, or they do, what does this method do that
Yes, Imo, you're right. They would use type name, and it works as long as the type is not generic. Because for generic types, you have this assembly name inside of the generic arguments.
Because the string that they produce is just this convoluted thing, I see.
Yeah.
Gotcha.
And I was just afraid that people will be like, oh, is this the dictionary of string to int? And they will be like, no, because it doesn't match the full name that's returned for type of dictionary string to int. So this is why I introduced this method. However, it has some drawbacks. And Jan and Levi were, against introducing this method. So I'm not willing to die on this hill. I just wanted to say why I introduced this helper method, because I wanted to make the life of our customers easier, and I was hoping that it will be simple enough to get approved. So this is my perspective.
So type name the type, right, actually has a representation for that, right? Why would we not expose this as type name?
We expose it as a type name. But the missing piece is that you need to take care of type forwarding on your own.
Don't we have something like, type name constructed from this known type and then compare them ignoring the assembly or something?
We don't.
And
that was in a very early prototype, but it never made the approved API.
And then what is the argument from the opposition? Like, why are Jan and Levi against having this method? Because you're asking the wrong question.
So, I am fine with having this method if it does what its name says. My problem is that if the implementation doesn't actually do type name matching, right? It's kind of sometimes compares exact type identity. Sometimes, it kind of compares the type name with the full assembly name, and it basically compares it as literal string. So if somebody makes a typo in the type forwarded from attribute and has extra space in it, it will actually fail, So I think this method is fine as long as it does what it name says, If it basically, for example, I would be perfectly fine if it basically just compares the type names and ignores all assembly names, or if it kind of compares the type names and simple assembly names and compares and ignores all, strong names, versions, and all that other garbage, right?
I would be fine with that. I would be fine with that.
I think that makes sense, honestly. I guess there are two main concerns that I have if we were to go that route. First off, the reason we're even having this debate in the first place is because this is an opinionated API. And generally, opinionated APIs don't really belong in protocol parsers. Like, generally, opinions are at a much higher level than the actual protocol itself. So the fact that an opinionated API exists here, on one hand, just strikes me as odd, but like I am willing to cede that as a convenience that we know that people are going to want, like maybe it's just something that I bite the bullet and say yes, it's okay. Second thing is I do wonder if the serialization record type is the right place to put this. I would honestly expect type name, the property, to move down to serialization record, and then this method to be hanging off of type name. That way it's like serialization record dot type name dot matches or something like that. I know that there's a little bit of weirdness there, but it seems like that would be a more appropriate place to expose this. Because if I want to check types for consistency, I don't actually care about the record, I care about the type name.
Yes, and I wanted to introduce it to the type name at the beginning, but the feedback I have received was that type name should not be anyhow connected to type forwarding, which is a serialization specific thing.
Yeah, that was the reason why we didn't do it on type name.
And it wouldn't be if you did the logic that Jan suggested, where you ignore the assembly entirely.
Right.
Yes, maybe the comparison would be a little bit more complicated, but doable, absolutely.
Yeah.
I mean, the other option is we just expose kind of like a matches method that has optional booleans that basically say what you're considering, and we default it in such a way that it happens to work well for binary formatter, right? Because I think most of the time people don't actually care about assembly names, considering that we have so many discrepancies between frameworks anyway that most of the time people don't actually care, right? They just want to know whether it's a specific well-known type name. So that would be another way to do it. I think the pushback was more about you processing the custom attribute, right? Which we wouldn't have to do in that flavor of it.
Yes. Yes, I agree now what Jan and Levi said make way more sense to me. So
then the conclusion is from class record we take type name and push it down to serialization record.
Well, first off, does that even make sense to do that? I know that you have things like element type.
It makes sense for almost all the record types. For those which we return to the end user for all of them, the only problem is with arrays, because for arrays I would have to create this name, because what I get in the payload for the arrays, I get the name of the element, not of the array. So I would just have to concatenate a string. So not a big deal, but
What about the library records?
They are not exposed to the end users, so
Okay.
They're free.
So if we were to move this onto the type name API, I would prefer for the method name literally just to be called matches. If we want to keep it on serialization record as a standalone method, then I would probably want to call it type name matches rather than is type name matching.
If we were to move it to the type name API, I would like the method to take string and not type, to make it clear that it's just matching string. It doesn't it's not connected to reflection.
Well, that's not really convenient for generics, right?
But if you just give me a string, and if it's a generic type, I would need to parse it.
Well, also the user would have to somehow know what format you want them in, right? Which there isn't the one format, right? So, is it C# syntax? Is it, reflection syntax? Is it whatever the underlying type name syntax is?
Yeah, I think it's kind of convenience API that kind of the semantics that it implements, it kind of it's very serialization specific. So, basically, like nothing in ECMA that the system reflection metadata is about matching type names while ignoring assemblies. Basically it's always
Right.
basically the whole ECMA is about type names in the kind of the system assembly.
I mean, would you be okay with an API that is along the lines of like type name dot matches simple name or something, and then you pass in a system dot type instance?
I think anything that takes system dot type instance is kind of bad design for type name. The system reflection metadata doesn't have maybe with like one or two odd exceptions, it has nothing to do with reflection, right?
Okay. So what if we still move type name down to the base class just because it is probably universally useful, and then renamed this method to type name matches, but leave it on serialization record, kind of like split the baby, as it were? Does that layering seem okay to you, Jan?
So we are saying just do kind of API changes in the binary formatter reader, right?
Yeah, so what's on the screen right now, that method stays on serialization record. It just gets renamed as appropriate. We leave type name alone, and we also add the type name property to serialization record just because we have it or can construct it.
I think that sounds fine to me. I don't know the format in detail, but kind of from the distance, it sounds fine.
I see. Because you could also imagine having a second argument to type name matches, which is an enum, which is like, how do you want us to handle assembly name or library names? And the values could be, must be an exact match, follow type forwards, or ignored entirely.
Yeah, there are like many ways, like you can have like completely custom thing that deals with whatever, your kind of assembly loader behavior is, right? So
the three things that I just mentioned are things that I've seen in practice across first-party code. There might be more. I don't know what they are offhand, but like if you want to do something truly bespoke, you have the type name instance already on.
Right. So what would we rename the method to?
If we have a type name property on serialization record, if we move the property down, then I would probably call this method type name matches, as opposed to is type name matching. It's the exact thing that Adam has already written, just kind of reworked a little more to follow our normal naming conventions.
I think that's fine.
And then you could imagine if you want having an extra enum as a second optional parameter, which is like, how do we handle library name matching?
Yeah.
I know it's complicating the design slightly, but it does handle the scenario that we've been talking about for the past few minutes, where the majority of people probably don't care about the library name and just want it to be ignored.
Yeah.
Or we just say don't even have the second parameter and we just always ignore the library name.
Yeah, we can always add the second parameter
later.
Yeah,
but I like the suggestion they provided. So it would be a simplified implementation that only compared the type names. And if you want to compare the library name, you would need to use the exposed type name information.
Right.
And if it turns out to be a popular request, we just add an overload with the parameters here.
Sure.
Yeah.
Well, I mean, I believe that came from Jan, not me, but yeah. Sure. And then I guess it doesn't need to be virtual at that point. It would just be non-virtual.
I would think so, yeah.
Yes, and this would solve some other comments that Jan had. I was doing some optimizations.
Yeah, because you have the type name property already on the serialization record, so in theory you have all the data there. Okay.
Yes.
That wasn't so bad.
I'm surprised.
No, I like that you've identified a lot of these common, customer scenarios and been like, okay, what can we do to make life easier for people, right? Like I think that is helping the design ultimately, even if we are having some back and forth about, layering stuff like that.
Yeah, thank you very much. My goal is to make the API easy enough to use so people don't switch to the OOP package and be like, it's too hard to use. I'm just going to keep using the binary formatter forever and be vulnerable to all of the attacks.
Well, I mean, I hate to bring it to you, but no matter how good your job here is, it's never going to beat give me an object. So it's
Yeah.
Yes, I know, but this was the tricky part of designing this API because it was like, I need to be safe, so like no recursion, no type loading,
Yep.
all of that stuff. But on the other hand, there is this ugly format from 25 years ago, and I need to create user-friendly API on top of it, so people don't get confused too much.
No, I mean, I'm only partially facetious. I think the job we're trying to do is as good as humanly possible. It's just reality is depending on what people use and how large the format is. You know, but also the goal is not necessarily to be as convenient as binary format, or just convenient enough, right? Because there's some domain differences anyway. So then I think next thing you want to talk about is the serialization record type.
Record type.
So
yes. So two things about it. The names come from the spec. I haven't made them up.
Right.
The other thing, I didn't want to include the values that we don't support because I wanted to spare the users from writing switch statements where they would have to handle all of them without knowing that they will never get such a value in real life.
Yeah.
And
so
there
I
are
agree with that.
four values. There is system class with members and class with members. These are the records where you need to load the type to find the field information. You have to turn on an optional flag in binary formatter to get this kind of output. We don't want to load types. This is why we prohibit that. The other two are related to remoting. It's method call and method return, if I remember correctly, and we just don't support it by design. So
Right.
That's my take on this.
I mean, I would agree with that. I think given that we basically just skip the values, if there's another need to expose them later because we, for some reason, have another reader or we, extend our reader to return those records as data, we could. But I think, to me, I don't know, it seems weird to expose values for which I mean, it's not like, if you want to look up the values, there's the spec. You don't have to go to the enum, right? And given that you can never easily encounter those values where the enum would be handy, you would have to parse the format yourself. I don't think it's super useful to expose them. I would agree with you that it's more important for people to write switch statements and know what they have to, that they actually have something that they handle rather than just throwing. That seems pointless.
On that note, some of those we don't expose, which we just talked about, right? So you
Like the header
you'll never
messaging.
see binary library.
Yeah, it is strange to me that we are exposing some things that we knowingly will never return to the user and making an opinion that these other things we're leaving off. We should probably either properly call the ones that we never want to expose or include everything, just for consistency.
That would I agree with. I would not do the half thing. Yeah, it seems weird to return values that you can never switch over either.
I think there is a way to get these other records, like for example, binary library. If you use the overload that gives you the record map, this record has an ID, and you get a serialization record. You cannot cast it to any public type because we don't expose it, but you can check the record type enum that it's actually the library.
Oh, interesting. So you actually do have a serialization record for a binary library then?
Yes, internally.
So that might throw off the plan to move type name down to the serialization record base type.
Do we actually need to use those records, or is that something, because if we make this thing opaque, we could filter those things out, right?
Right. You'll never see the
with the
records
current deserializer. I mean, if there's no extra data on those things, if we just had something that was had an indexer basically, or try get on it, right? Some method, then we could actually do filtering. So, like, yeah, sure, internally we might be keeping that for some reason, but like, you never need to see it from a public API perspective. So why expose it?
Well, like, binary library doesn't even have an object ID. It has a library ID. And library IDs can overlap with object IDs. So, like, I don't even see how you could return it as a serialization record.
I think the binary library record has its own ID.
Right, but it's not an object
Yes.
ID. Like, you can actually have an object with ID 1 and a library with ID 1, and they don't conflict.
In reality, I don't think so. But according to the spec, maybe.
Okay.
So the binary formatter won't do that. Now, that said, the binary formatter does have some bugs where it generates duplicate negative IDs in some cases.
Yeah.
So with all things binary formatter, consider there to be unknown caveats.
Right.
So then, like, logically then, so we can do one of two things then. We can either say we don't move type name down, or we can say we have a notion that some records may not have a type name.
If we don't ever, I mean, we have the usage of this stuff, you know, for a full deserialization stuff. If we're not actually dereferencing those ones that we don't need to know about, then maybe we should just filter them and go for the simple answers for these. It's like, you only ever see the things that are actually used or would be used, right? You never see the record IDs or record type IDs for types that aren't really going to be that we've abstracted away within the current system, right?
Mm-hmm.
So that would mean either you'd have to put a wrapper for the iDictionary thing. You could still return the iRead-only dictionary, but you'd have to some sort of, you know, interceding in the middle. But anyway, that's my 2 cents.
Yeah.
2 bits.
So then, I suggest we just don't discuss them. Then we just take a note and say, you know, either expose them all or subset them to the ones that are actually publicly visible,
Mm-hmm.
and then leave it to Adam to actually walk that list and see what is actually reachable by the public API.
That seems good. And I think that matches what Jeremy Barton said right before he went off as well.
Well, I think
I think he wanted everything on it.
Yeah, he wanted everything that's in
Yeah.
the spec. To me, that it's I mean, I'm of two minds here, but I think generally speaking, when you have a reader that is for API usability reasons already a subset of the spec anyway, I think at that point you have to decide which side you're on, right? And I think we already said we want to be a subset of the spec because, well, we don't want to expose all the things that we don't think are good to expose, so might as well. Sorry, I'm in the wrong window again. Here we go. No, that's the other. No, it wasn't the right. This is the one. Here we go.
Yeah, record type. So I guess the only other feedback I had on the enum is I mentioned this earlier. It shouldn't be backed by byte. It should just be leave it backed by int as normal enums are. The reason being that if you back an enum with a different data type, normally that indicates that the enum is meant to be within a structure that's being marshaled across like p-invoke boundary or being splatted directly on the wire, stuff like that. But in your case, like this is an interpreted enum. Like we're reading something from the wire and then projecting it separately as an enum rather than including it as part of the type itself. Or sorry, as part of the struct itself.
Yeah.
And in that case, like int enums just work better for everyone.
I already took the note, yeah. All right, so
Good
then...
point. I didn't think about this.
All right, primitive type record.
Yes. So internally, binary formatter has different kinds of records for different primitive types. Like it has one for string and another for ints, characters, etc. So this is like a abstraction for them. So it can be, the T can be string, int, and all of the types supported natively by the NRBF. The constructor is private, so nobody can derive from it, and the only thing it exposes is the value of T.
So I'm looking back at what SystemText.json did, and I believe that it looks like they actually have a non-generic class that would sit between primitive type record of T and serialization record, where the value property is boxed, regardless of whatever it might represent, char, int, string, Soviet. I guess the benefit being that if it is a primitive, you don't actually need to know what the T is. You could just cast the record to primitive type record, untyped, read the value, and then call convert if you need to. Is that something that you think would be beneficial here?
So to be honest, when I was switching the serializer to this API, I was thinking about this because I had to write the switch 2 times, basically. So I would find it useful in those 2 places, but it would incur boxing, which I didn't want at the end, and introduce one more public type. So
I mean, you wouldn't have to, right? You could say you have a virtual property on, or an abstract property on the one that is non-generic, and then the storage is basically just, it's only boxed when somebody queries the object one, right? You don't have to
boxed on demand.
Yeah, the boxing is not mandatory, but having new type is.
Yeah, but that also helps some other patterns, right? Is to be able to go and say, like, is this it's hard to check, is it primitive type of T when you're writing code, right? It's like, I want to know if it's some sort of primitive type record. You have to check the generic, you have to check to see if it matches the generic base, right? It's much easier to say, is it a primitive type record, and then go into the other things. I did that via an interface,
right?
But a base class with object is also, or a lazy object boxer is also a totally valid pattern, right?
Yeah, and an interface would work too, like Jeremy said. I guess one of the other things it helps with is if you're using reflection to set property values or to set field values, like everything's going to end up boxed anyway, so you don't actually care what the T is. Like you're just dealing with objects the whole time.
Yes. So I agree that it would be useful to have, and most likely it would solve the problem of people not needing to remember all of the types that are natively supported and considered primitive. Because, for example, datetime and timespan is, but GUID is not. So the check would be way simpler.
Yeah.
I like the base class one. Is the better of the two, I think. My opinion.
Yeah, so far I haven't introduced any interfaces here, so it would be like kind of consistent.
Yeah, I'm also a fan of the base type.
And with interfaces, I'm not sure if I would be able to prohibit anybody from inheriting from that.
No, you're not. I mean, like we could at some point consider doing what Roslyn has done, right? They have this special marker attribute that they can put on interfaces, and then when you code against Roslyn, you get an analyzer that basically produces an error when you try to extend their interfaces. But so far we haven't had the need for that. I think in general, like I would say, this is a prime example where a base type is a better choice.
Agreed.
All right, so then class records. No, again the wrong window. Here we go, class records.
So by the way, with the base, sorry, just backing up a little bit before we sign off of that. So the base class would have public object value, and the derived class would have public new T value. Is that what you're saying?
And then it would override the other one to... I guess that's the question. How do you override the other one? You would have to basically have probably an internal abstract thing that
Yeah, we can
serves
make
as an
that work.
intermediary area. But yes.
Okay. But the public APIs, you would prefer method hiding, basically.
Yeah, I would prefer to have them
Okay.
the same property, because like the same name. It would be weird to have
Okay.
like, base value and value, for example. But I would call it value in both times, and then if you invoke it on the base type, you get an object that's boxed, and if you call it on the derived type, you get the unboxed version.
Sounds good. Yeah, sorry to interrupt you, Adam. I just wanted
Yeah.
to make sure we were clear on that before I moved on.
That was a very good question. You have actually solved me some trouble for tomorrow when I will be implementing that. So, class record. We know how to represent primitive types, but the other kinds are classes. And the name is quite confusing because it can also represent struct.
Right.
But I have reused the name from the NRBF spec. And it's, what we get. Of course, private constructor, so nobody can derive from it. A type name, because we know the name. An enumerable of strings which are member names. Members are either field names, or if somebody provides a custom serialization constructor, the value they have set. Then we have methods for checking whether a given member exists. This is useful for versioning. For example, you have renamed a field and you want to check whether it's v1 or v2 object. A set of helper methods for getting primitive values, like getString, boolean, etc. Could you scroll down a little? The other are getArray of primitive type of T, so getting a single dimensional zero-indexed array for the subset of natively supported primitive types. The other are getSerialization record, where, for example, in a class you have a reference to another class. This will be represented as another serialization record and class record in that case. Just for convenience, get class record. So if you expect it to be class record, then no need to cast. And last but not least, get row value, which for primitive types like ints and strings returns the row value. For null records, it returns null. For other types, it's either a class record or an array record. And this method is useful for the deserializer, where you just iterate over the fields from the serialization info, and you just, you want the value no matter what it is, and you move on. Are there any questions regarding class record?
The array of primitive type. So this is NRBF primitive types, right?
Yes.
So would it be more useful to have the only reason you have a null in here would be because one of the primitive types is string?
Yes.
So would it be useful to bifurcate that?
You mean like have two overloads, one for strings and other for all of the structs?
Yeah, because there's no nulls in the other case, and we have the question which we haven't touched yet here either, is that with the case of the nulls, you have these coalesced null records, right?
Yeah.
But for the primitive case, that's true too, right? Even for the
it's
string
impossible.
one, is that?
No, for string you can have them, but for integers and else not.
Yeah, for the other ones I know you can't, but for string, I'm just trying to remember off the top of my head. For string, you can still have the coalesced nulls, right? So
yeah,
even if it's the primitive, well, string has its own. To be clear, string has its own specific array record type. So yes, it has the coalesced thing. So
do we have an attribute that we can put on the allow nulls parameter to somehow? Probably not, right? Because it would be an element. Yeah, we probably can't do that, right?
Well, one of the interesting things is if later in the spec, Adam has specific array records which tell you how many elements are in the record. before you actually try instantiating the array. This, because it's an accelerator, doesn't actually give you that information.
Right.
It just creates the array.
So, or we just exclude string from this one altogether, right? And make that one come from because that's also one, or do we have to have this here?
We don't have to, because
For
the users
string.
can call get serialization record, and they are going to get an array record of string.
Right.
And then they will be able to call get array.
That would be simpler, right? Because you wouldn't have to have the null nulls or anything. If this one just handled the real primitive ones, and they're safe, right? Because we know in all the primitive cases that we have that much data, right?
Yes.
I mean, you could have an accelerator that just returns an array primitive, right? You could say get array, right, and that gives you back an array record.
True. That would probably be the safest thing to do, because then you could also look at the length and everything else.
Right.
Before you choose to rehydrate it.
I agree.
I think I prefer that too. And then I guess the pattern is for each member in member names, and then call one of those.
Could you say that again, Emo?
So I
you just
assume the pattern is like for each member in member names, and then inside the loop you're switching over the member names, and then based on what you know about those member names, you call one of those specific methods, right?
If you scroll down to the samples, I have a sample of how this is used. The first sample a little bit up, slightly up. Oh, here. So we have a class called sample that has an integer, text, string field, and byte array, and a reference to a type of it's the same type. And as you can see, you know what type you are expecting. So you call get int because you believe it should be an int. You call get string because you are expecting a string.
I see. So you never really need the member names then. Yeah, you would only need the member names if you don't know the types.
So, Adam, I have a. Go
on. Should there be a key value pair enumerator instead of just the keys enumerator and then the gets the get value? Because a keys enumerator followed by get is in squared, in login, in potato. Like usually for each key, go get the value is a bad pattern when you could have given both the key and the value at the same time.
I mean, I guess but
this would require some. This would require some extra work, because the way it works is typically if you have multiple occurrences of the same type inside the stream, you have one class record, custom instantiation of class record that comes with all of the member names. So you read it once, and then the other ones are of a different type that just say, I'm of the type that you have encountered previously. Like there is I give you the ID. So you don't get the member names again, but you just get the values. So if we were about to expose names and values, we would always have to, allocate it.
If in order to return it where it looks more linear, you'd have to do the n squared work yourself, then may as well make the caller see the n squared work.
Yeah. So then, presumably, then the primitive that people would call is so the non-accelerator is just get serialization record, right?
Yeah.
So, Adam, silly question. Let's say that I have a person class, and the person class has an age field, and age is nominally an integer. So the NRBF specification differentiates between an inline integer and a boxed integer. Do you differentiate here as well?
They are both going to be handled.
So if there is a record which says I am not a primitive integer, but I am a boxed integer, do you, under the covers, make that look like a primitive integer, or do you expose it to the user as a boxed integer? And by box integer, I mean it has the name system element 32. It has a field called underscore underscore value. And underscore underscore value has a primitive int value.
I think that in both scenarios, getInt would return the value, and getSerialization record would throw if it was actually an inline primitive, and return the serialization record if it was the right record for this type.
Okay, so you have some type of logic in here to kind of paper over those differences. Got
Yes.
it. Okay.
The only time you get a boxed one is when either the root record itself, right? Because you have an int is what you serialized, which you can do. Or you have it, it won't arbitrarily do that unless you're actually casting it to something. Like if you have object field and it has int, right, as part of your object field, then it will be a boxed int, right?
Right.
Or some other thing that int derives from, right? Like iComparable or whatever.
Okay.
Is the field type, right? Or the member type.
And one more is array of nullable types. So there you also have this kind of records.
Then I guess offline we can talk about how that papering works for more complex types like datetime, because like primitive datetimes and box datetimes are represented wildly differently on the wire. So papering over that's going to be fun.
Sweet.
Yeah. So this is also one of the reasons it's very hard to write a safe binary formatter parser, because like it was never intended to be anywhere close to safe from the beginning. Fun times. Okay, cool.
Sweet. I guess now we can talk about array record then.
Yeah. Array record is an abstraction for all kinds of arrays, meaning single-dimensional, jagged, multi-dimensional, and also with the same thing, but with the custom offsets. What it exposes is a read-only span of integer for the lengths, so it can represent any number of dimensions. A rank, binary array type, which is an enumeration that describes what exactly it is, and element type name, and a possibility to get the array. Here is the tricky part. I didn't want to allocate any array people were asking, because let's say you have a class with an array of bytes, and then somebody sends you a class with an array of strings. I'm not going to allocate the string array for you until you give me the right type. So this is why you have to specify expected array type up front. And I'm doing the matching inside, and if there is a match, I'm going to allocate for you. And because you gave me the type, it means that this type was referenced, and the code for it was not removed by the linker.
So what is binary array type?
If you scroll down, there's it's another enumeration. It's either single, jagged, or rectangular.
I see.
And there is also the variation with offset. And we had a debate on GitHub whether we should actually support custom offset arrays. I have implemented the support. I've implemented that. We can have it, but it's.
I personally think we shouldn't, because we don't handle everything anyway. It's like to have an array that starts at an offset of 1 is going to be highly unlikely that people are actually doing that.
Yeah, not even VB.
Legacy VB maybe.
No, I mean even VB defaults to 0.
So VB got rid of that when it moved to VB.net.
Yeah, well, you can still create fun-based arrays even though it's not the default, is what I was
Sure,
getting at. And I don't know if people do that.
Well, sure, but you have to use the array class to do it.
Sure.
And then anybody who takes an array is going to fall over, because no one expects length to be 1 and index 0 to be invalid.
Yeah.
Right. in any real written code. So I would rather not let people see this at all, and like would fail if we see them.
Well, they're also
from
different
a
types, right? They're not assignable, so you have to have an overload that takes, capital A array, right? You can't take
Correct.
it in bracket because that's always a zero-based array.
Right.
So yeah, virtually.
That's
I mean,
fair.
given that almost no framework
Yeah.
APIs take them, I'm sure users are doing it, but I don't know. Like that will be. We can wait for it to happen.
Well, the
Yeah,
APIs that
I-
Adam exposes there's a read-only span of int, which is lengths, but not a read-only span of int, which is indices,
Right.
or lower bounds, or what have you. Which made me think when I first looked at it that it didn't support anything other than zero-based.
Ah.
Yeah.
It does. I am happy to remove it. And one more thing, when I was implementing the support for that, and I was writing a test where I was using binary formatter to serialize such arrays and then read them with my payload reader, I have found at least 2 bugs in binary formatter where it actually doesn't support them properly.
Okay,
Cool,
so
that-
then that answers that. My other question is: Can we rename this type to something that doesn't include the word type, like kind or shape or something? Because this is not the type of the array, right? It's the, you know what I mean? Like it's like type is overused in the sense that it seems confusing.
That's fair. I think that most of these were starting from the spec name.
Yeah.
Right.
Yeah.
So, which isn't particularly API friendly.
Yeah, to me, like also the notion of binary seems odd here. Like if we just call it array shape or array kind, I think that would be slightly more intuitive.
They only, because they only show up with binary array records, which don't include the print. There's like multiple array record types, right?
Which
so
we only expose to,
they're-
right? We only expose array record and array record of T.
Well, we do, yes.
We don't know.
I'm not sure.
Or we already exposed the rank, so maybe I could just also, because I could just expose a Boolean property called is jacked, and if it returns false and it's 1, it's like...
Or you can just say single, right, for all the other records, right? You can move that up to the array record.
So are you contemplating getting rid of this enum entirely? That is that kind of the crux of this discussion?
Yeah, that's my idea, because it would save us the naming problem.
Sure. And if you're not supporting anything other than 0 indexed, like half of these don't make sense anyway.
Yeah.
Well, but then you still have 3, right? Because rectangular and jagged are different.
They are, but I do wonder if that's actually something that people really care about, though, because like you don't even need an is jagged property, right? Because I can look at the elemental type name and ask if the elemental type name is itself an array.
True. So, I mean, the only one that really matters is whether it's multidimensional.
Which you can get from the rank.
True.
Well, let me back up. There is an edge case where you can have an MD array of rank 1, which is still 0-based, that is not an SC array. Like, do you care about that, or is that just such a weird thing that we don't want to support it? Basically, what you're doing is you're using the array.createArray API to say, like, I am creating an explicit rank 1 array and passing you bounds. I'm just happening to give you a lower bound of 0 and the length of so be it.
Seems worth testing. Like, given what Adam just said about the other array outcomes, I wouldn't be shocked if it just doesn't even work with binary formatter properly.
Okay.
I mean, if it does...
There's all sorts of weird caveats with the array stuff, because like with the multidimensional arrays, like you can actually have rank lengths of 0, which you can't actually use, but like you can create those arrays. So
an array of rank 0 means what?
Well, you can't index it, right? Because you can't, like, but you can create it. You can create a multidimensional array that's 0, 1 is the length in C# even, right?
So it's like a tuple of rank 0.
Yeah. But you can't reference anything because you have to give both indices, right?
Yeah.
And the one is what's between 0 and 0? Nothing, right? So
Yeah.
there's all sorts of fun stuff with arrays with this stuff. Anyway, I'll stop.
Sounds great. So then, I think what I'm
So
hearing
we
is
should investigate getting rid of this Enum.
we might want to get rid of the Enum. That's what I'm hearing.
Yeah.
And then see where this goes. So
One-
I think I have all the things we talked about. I'll paste it in here, and then we can
Yeah.
see whether I missed something.
Another thing that we're going to want to discuss, Adam, is how does a user actually know how many elements are in the array?
You have the length property for single-dimensional arrays and the lengths for all other. So
I don't see a length property. I only see a lengths property.
Sorry, we haven't discussed the array record of T.
Well, okay, so let's look at the base array record, right? There's a lengths property.
Yes.
How do I know how many elements are in the array if I want to do some type of check-in before I actually allow it to be allocated?
You need to do
You see where I'm going with this.
Yeah, I think I know where you go.
Should we have the long lengths to match the array? I mean, the long length. It's what we call it in array.
I
right?
already have an
The
internal
flattened
one
length.
for this, so I'm happy to expose it. But there is a question, like, should it also... Because the information I get from the payload, it has the total number of elements for single-dimensional and multi-dimensional. But for jagged arrays, it just gives me the length of this jagged array, and then the other arrays can have, different numbers of elements. So should this property for jagged arrays as well return the total number of all elements? I believe most likely yes. So people don't.
Considering that you have a single method that does all the allocations, yes, because that's the thing you want to bound, right?
Okay.
Well, that's one of the two things I was getting at. The other thing I was getting at is, like, I have a read-only span of int lengths. How do I know the total? Like, I would call...
You need to do the math on your own, but I'm happy to expose this information.
Yeah.
I already have this because
how
using it here.
how many of our developers actually use checked blocks in their code?
But you won't need to use checked blocks because if there is an overflow, I'm not going to parse this array. It's going to get rejected. If you give me more than int max value, it's going to
Or
get rejected.
The total number of elements cannot exceed int.max value
Uint
across
max
all the
value.
different dimensions.
Uint
Uint
max
max
value.
value.
Yeah.
Didn't we settle on that? I mean,
That's still
for a multi-dimensional array, you can technically have more than int max value.
I don't think on .NET Framework. I think on Core, yes. I don't think on .NET Framework. I think we tested that a while ago.
But for the purposes of binary formatter, that was one of the things that I did as a restriction because I felt that was, well, it added more complexity when you had to when you're like, sometimes the long is okay, sometimes it isn't. Right.
So let me very concretely get at what I was afraid of then, which is, like, if I'm trying to limit the return array to 100 elements, I'm going to say, okay, how many elements are in the array? Like, for each for each bar x in lengths, add them all up. And then, is the final number less than 100? Well, negative 1 billion is less than 100. Yes.
Right.
Sure. I mean, but that's something that we can guard against. But
well, who's we? We being the creator of the APIs here.
Yeah.
So, Adam, you're saying that you would never support more than int.max value elements in an array?
No, it would have been long, right?
To be exact, for single-dimensional arrays, I support array.docs max length.
Sure, yeah.
For multi-dimensional, I support int.max value because according to the testing I have done, this is the actual max length of multi-dimensional array in .NET.
Right. And what I'm getting at is that is surprising to people. I think people are going to look at the lengths property, assume that the math that they want to do over it is accurate, or is correctly written, and then be very surprised when their applications and crash.
I think what we concluded was that we would have a method that gives you the total number of elements in the appropriate type, which would probably be long, right? Because we need to support at least in un.max value, which is more than int.max value, right?
Yes, it could be uint. It could be uint.
Do we really need to support that? I mean,
yeah, I would say
for a regular array, you can't have that. Like you'd have to have like I looked at the amount of data that you would have to have like, let's say byte was the array. You have a multi-dimensional array of byte that's long, right? I mean, you're quickly getting over 4 gigabytes just with that.
Oh yeah, the stream itself is going to blow up at that point. This is really an issue when you talk about like that compressed null stuff.
Sure, but like even then, it's like the cases where we would have that, I would be concerned that those were never actually really going to happen in real life, and you're introducing another vector of attack. Like when you have to sometimes do like that overflow thing. Like if we're always just saying, the most you can ever have is int max value, then you never have this thing where this time I need to be worried about it being a long or an int, and we just say we exclude those cases for another simplification piece. But that's just my opinion. Is like I think
what you're proposing is a kind of a variant of what Levi was saying. I think what we want is a method that basically does the math on behalf of the user to allow you to have a bound. You're basically saying we don't need to support anything more than int, and can just say if you find uint.max value in the payload, something terrible has happened anyway, so we don't even allow that. But it would still avoid the overflow situation that Levi was concerned about.
Yeah. But like that's just taking it another step forward to say like the most we'll ever give you is an int, so you never have a problem with overflowing. And like if you have some if you just happen to have like an 8 gigabyte data stream coming in with just a multi-dimensional byte array, then sorry.
Yeah. I mean, you've got other problems. I would say like the one scenario might be worth looking at is things like paint.net, right? Because I know that they serialize their shit using binary formatter, or at least they used to. And
they still do, but it's still you're not gonna have a byte array that's over int.
Yeah, it wouldn't be a byte array, I guess that's true. So like how do you store your freaking image, right? Do you do it as a multidimensional thing? Probably not, right? So I don't know. Maybe it's not a real scenario.
So introducing a long length property would probably be the right way. One of the right ways to resolve it, just as long as we make that very obvious to people, saying like, hey, don't try doing the math yourself because you probably aren't doing it correctly.
Well, yeah, I think we should have the property. I'm just also arguing that we should cap it int, so that so nobody has to do. That's another thing that they don't have to figure out, right? Yeah.
So what you're saying is
it's single dimensional, so that's not valid.
So we have an API that returns the total number of elements, computed out if it's a multi-dimensional array, a jagged array, whatever. And we are saying we return this data type as an int, and we blow up if it's exceeding int.
You can do that if you want to.
That sounds fine to me.
That's my recommendation, just because it simplifies the logic both internally and for the users. And yes, it does technically exclude things, but we're technically excluding other stuff too. So, like not non-zero indexed arrays and other bits and pieces in there. Like the odds of it getting hit are next to none. Where we wouldn't be punting people off anyway. It's like, really?
Yeah, it's even hard
8 gigabyte multi-dimensional array.
I could buy that argument.
Of 8 gigabyte elements. Let me be clear. Like.
It's even hard to generate such array because memory stream is backed by an array which has the default limit. So you actually need to create either a file stream or an unmanaged memory stream.
Yeah.
I know because I implemented test for that, and it works. But I would be happy to remove it.
I'm not going to die on the hill. I just think it's better. So.
I'm fine with that. So we can limit it to array.max length, and say that this is the max length we support, which is slightly less than int.max value.
Yeah. Okay.
I think that makes the most sense. Anything to say about the record of T?
Yeah, so I expect that single-dimensional arrays are going to be the most common. So this is why I wanted to provide people like a possibility to check, is it an array record of int or of string? And give them the ability to just,
You would never have something like array record of int, right? It would always be a primitive, right? The T.
So the T can actually be either one of the primitives or class record, because arrays of classes are represented as array record of class record.
Gotcha.
And for NRBF, the spec, you could technically have an object record that had int as the base type, but binary formatter never does that. So you could compose a payload that looked like that, but binary formatter wouldn't.
Would you? So array record of T, should that be renamed SZ array record of T, or are we good with array record of T? We actually do use the term SZ array for single-dimensional zero-based arrays.
That is a great question, and I think it would be the right thing to do.
I mean, we have
done. Oh,
this.
Simone, what have you done to us?
I mean,
well, this is where I kind of wish Jan was still here, because I think he has opinions on SZ array naming, but I don't remember what they are offhand.
I mean, we have it in reflection. We have I think, an is array property somewhere. I mean, I'm okay with that. I mean, it seems like a specialized case.
We have is SZ array on type delegator, on metadata type name, on system type, on type builder, on enum builder, and on GTP builder. So
yeah, it's the actual terminology we use. Yeah.
So then we call it a Z array of T.
Yes. My only problem with that is that I believe that most of the C# developers outside of .NET team have no idea what SD means.
Mm-hmm.
So
that's fine. The vast majority of people will not be able to read this payload either. So.
But I mean, we don't want to make it confusing for them, though, right?
Yeah. I mean,
but maybe we say, like, you know what? You looked at the documentation and you see that SC array reader, the type, literally means single-dimensional zero-based array.
And we call it SZ with a lowercase z?
We use uppercase Z everywhere else in the framework.
Yeah, that's always...
All right, then uppercase Z it is.
So we're renaming the whole type?
Well, how else would you do it?
I thought we were talking about is SC array property.
No, there is no SZ property. I'm just saying we had this in reflection. We have two types, right? Array record and array record of T. So if we want to return something, we would have to, rename this guy here, right?
But is array record of T is always the SC array? I guess it has to be because it has a
yes.
array.
Yes.
Okay. So it's not just a typed array; it is a typed SZ array. Okay.
Yes.
Mm-hmm.
Yep. They have to make sense.
That's what I said. I think to me it would make sense. Yeah. Sweet. Then let me do that here.
Well, we got through almost everything.
I think we got through all the APIs. You may not have gotten through all the samples, but we talked about everything. Let me go back to this here. Let me hit comment.
Oh, Adam, question. The getArray method, is it creating a brand new array instance every single time, or will it return an existing array reference if you have back references?
If it's an array of primitive types and we have already materialized it, it's going to return an existing array.
Okay.
And if it's object bracket, aren't you going to return the same thing twice if they call it twice?
Currently no, but I can change the implementation to just be consistent.
Yeah, it should. I think it'd be good if it consistently calling it twice gives a reference equals the same object. Just means you need to add a field to save it after you've returned it once.
Right.
Because it's the exact same record at that point, right? That's kind of what you're getting at. Yeah.
Yeah.
And the
part
record
of
has
why
now
it
been
got
materialized.
renamed from toArray to getArray is so that it could return the same thing multiple times.
Yeah. Because that addresses one of the other questions I had that I asked offline before all of this. Okay.
All right. Related to the binary formatter removal effort, there's the NuGet package that will be created from it. Does anyone want to tell me that I need to come back on Tuesday, or can we take the name system runtime serialization formatters dot new package because that's the name of the DLL inside it?
Yes.
All right. Wait, was that yes? Use that name, or yes? Come back on Tuesday.
I leave that to you.
I mean, that seems like something you can just email about, and then everyone
Yeah,
will
I
just
think-
rubber stamp it.
It seems like very uncontroversial to just pick the name of the assembly.
Yeah.
All right, so then I mark this as approved then. I left the feedback in there. And then we're done with this for now, right?
Yes, it seems so.
Sweet. Then I see the rest of you on Tuesday. I don't know exactly what the agenda is going to be because we have requests from the Azure SDK to look at something that they want us to ship. There seems to be some controversy around whether we think it's ready for that kind of review yet. If not, we do backlog because there's enough in there. So we have something. What it is, I'm going to figure out over the next days. All right. Then everybody have a great weekend and enjoy whatever you're going to do.
Thank you very much.
Bye-bye.
Bye.